We've looked at translations before, and if you remember, anytime you want to shift a graph up, all you do is you add the factor to the entire equation. So we'll add it to f of x, and as you can see, the little rule right here is you take your equation, the original one is always f of x, and we'll plus a to the end of it. If you want to move your equation down, you're going to subtract the factor from your original equation f of x. So it will be f of x minus a. If you want to move something to the right, you're going to subtract the factor just from the x. So instead of the number being added at the end of the equation, you're going to subtract it just next to the x. And if you remember, whenever we're dealing with horizontal, it's kind of the opposite of what you would think. So if you want something to move to the right, you're actually going to subtract it. And then if you want to move something to the left, you're going to add the factor just to the x inside the parentheses. So these things right here, those are called the rules. And our original equation is always going to be f of x. So when we look at example 1, our original equation is x to the third plus 4, and we'll use that for all of the examples. So our job is to match the rule that they gave with the type of change and then write the new equation. So I can see, since we are adding 3 to the entire original equation, f of x, this is going to be a vertical shift up. So we'll put vertical translation, we'll just abbreviate it. And since it's plus 3, up 3 units. And so now we'll actually do that. Let's write the original equation, the f of x. So our new answer, g of x, will be x to the third plus 4, and then we'll add on the 3 at the end. When we combine like terms on that, it just becomes x to the third plus 7. So that's the new equation. If you were to type the original equation, f of x, and the new equation, g of x equals x to the third plus 7, you would see that it moved up 3 units. So when you go to do example B, since the 5 is being subtracted from outside, this will be a vertical translation, and since it's minus 5, it'd be down 5 units. And we will write the equation as g of x equals the original one. The original f of x is x to the third plus 4, and we will subtract 5 from it. So when we combine like terms, we get x to the third minus 1. When we look at example C, I notice that the minus 5 is inside the parentheses. So that automatically makes me think horizontal. And since it's minus 5, I know it'll be the opposite, so not to the left, but to the right. So we'll say a horizontal translation to the right 5. So let's write that equation. We'll say g of x equals, and now we're going to write the normal equation, but right next to the x, we're going to write minus 5 next to it. So I can see the very first part of the equation is x to the third. So I'm going to write x minus 5 to the third, and then keep writing the rest of the equation plus 4. We actually don't need to do anything to simplify that because that's in vertex form, and that is an okay way to leave your final answer. When you go to do G, our new equation, g of x, will equal the original one, but with x plus 2 in the place of x. So it will be x plus 2 to the third plus 4. And I forgot to name the type of change. It's going to be inside the parentheses, which means horizontal. And it says plus 2, which will actually mean to the left 2 units. Now for reflections. If you would like to flip your graph across the x-axis, remember the x-axis goes this way. And so what you're doing is you're flipping from top to bottom or bottom to top. So you are going to flip all the signs on the entire equation. So you can fill in f of x there, or if you remember that that's going to apply to the entire equation, you're just going to flip all the signs. So here's the rule for that. Just negative and then f of x. So you'll flip every single sign. If you're flipping across the y-axis is up and down. This time it'd be a flip from left to right. So the only signs that will change will be the signs on the x's. So this time the rule is you only change the signs in front of the x. So let's try example 2. 2a wants us to flip across the x-axis. We're using this as our original equation. So the new equation, g of x, the rule is this one right here, that we have to flip all the signs. So instead of positive x to the third, it'll be negative x to the third. And instead of, I think that was a minus sign, it's not showing up on my paper. Instead of minus 2x, it will be plus 2x. And then instead of plus 4, it will be minus 4. So all we did was flip all the signs. On 2b, this one we're going to need to flip across the y-axis, so we're going to do the rule right above that. We're only going to flip the signs on the y, on the x's, to flip across the y-axis. So the new equation, we're going to flip the first sign, so not positive x to the third, but negative x to the third. We'll flip that minus 2x to plus 2x. And then that last number, the plus 4, it doesn't have an x by it, so it stays plus 4. The last type of change we will look at are stretches and compressions. If you want to do a vertical stretch or compression, you're going to multiply the whole equation, in other words, f of x, the whole original equation, by whatever factor they give you, a. You'll know it's a stretch if a is a whole number out front. You'll know if it's a compression if your factor is a fraction out front of f of x. If you have a horizontal stretch or compression, on the other hand, you're only going to multiply the x's, this time by the reciprocal of your factor. So if they tell you your factor is a, you're not going to multiply by a, you're going to multiply by 1 over a. So for that reason, a stretch, you're going to see the 1 over a in front of it. It's kind of the opposite of what you would think. Normally a stretch would be getting bigger, but we'll have the fraction for that. And then the compression, you'll see the whole number. So let's figure out what types of stretches or compressions these are. They gave us the rules, and then we'll write the new equation. So in 3a, they said it's 2 times f of x, and that matches up with the rule right above it with the vertical stretch or compression, because it's right out front. Since 2 is a whole number, it's a vertical stretch. So first we'll jot that down. The factor is 2, because that's the whole number out front. So we say a vertical stretch by a factor of 2. Now we will write the new equation. G of x equals 2, and now instead of writing f of x, we're going to write down all of that inside parentheses. 2x to the 4th minus 6x squared plus 4. The last thing we have to do is just distribute the 2 by multiplying it by each of those numbers, and we'll be done. So 2 times 2 is 4, x to the 4th. 2 times negative 6 is minus 12x squared, and 2 times 4 is 8. So that equation right there is the final answer. If you were to graph the original and the new one, you would see that the new one is stretched up taller. Now for the last one, 3b. First, let's identify the type of change. The 2 is inside the parentheses with the x, so that means it's going to be a horizontal stretch or compression. But we just have to figure out which it's going to be. Since 2 is a whole number, it's going to be a compression. So we will say that this is a horizontal compression by a factor of, and the factor is always the reciprocal. So if we're having a factor of 2, it means that it started out as the reciprocal of that when the problem was started. So the reciprocal of 2, if you flip over 2 over 1, becomes 1 over 2. So that's the factor for that. Now we just need to go ahead and plug that into the original equation that we gave over here underlined in red. So the new equation, g of x, will be, let's see, we'll start writing the 2 from the original equation, but instead of writing just plain x to the 4th, we're going to write 2x, because we're multiplying the x's by 2 to the 4th. So the 2x goes in parentheses, and to the 4th power goes on the outside. We'll keep copying the rest of the equation, minus 6, and then instead of having x to the second, it will be 2x to the second. And then last we have plus 4. Next we need to follow order of operations and deal with the exponents. So we need to distribute the exponent of 4 to the 2 and the x. And we need to distribute this exponent to the 2 and to the x. So the next step would be 2, and then this is going to become 2 to the 4th x to the 4th, and then minus 6, and that next part will become 2 to the 2nd x to the 2nd, and then plus 4 at the end. So once we're done calculating this out, we'll have the final answer. We have 2, and now 2 to the 4th power, that's 16, x to the 4th. I'll recopy the minus 6. 2 to the 2nd power is 4, x squared, and then the plus 4 gets recopied. Now the last step is to multiply the coefficients. So 2 times 16 is 32, x to the 4th. Negative 6 times 4 is negative 24, x to the 2nd, and the plus 4 just stays at the end. So that's the final equation. If you were to graph the original and that one, you would see that this new one is compressed horizontally, so it would be narrower.